for practice, measuring angles. The one at the top, what we're going to do is use the diagram below. In exercises 1 through 11, find the measure of each angle. So the first angle is angle MLN. So MLN. Now this one's pretty simple because we know it's an acute angle. Looking at it, we know it's less than 90 degrees. A right angle would go at 90 degrees, so it's less than that. So we use the smaller number. And because we go from 0 to 60, really it's the absolute value of the coordinate of this ray, LM, and the coordinate of this ray, which was 60. So 0 minus 60 or negative 60, its absolute value is 60 degrees. The next one, NLP. NLP, this time we're not having 0. Okay, we don't have 0. So we choose which set of numbers. It really doesn't matter. You just have to stick with the same set. For instance, if I want to look at the ray here, and I'm going to use these numbers on the inside. So this ray LN, it corresponds to 120 on my protractor. And so when I use ray LP, it corresponds to 50. You couldn't use 120 and then use 130 over here. You couldn't use 60 and then use 50 over here because that's definitely not a 10-degree angle. So using 120 and 50, 120 minus 50 would be 70. So the absolute value, that's 70 degrees. We know it's not a 10-degree angle. A 10-degree angle is 0 to 10. That's small, right? So you know that it has to be, you use the same number, 70 degrees. On the next one, NLQ. NLQ, this time the ray with NL, I'm using 120 because I look at this angle, I see that it's more than 90. Look at the interior of the angle, look at the distance between the two rays. So this time I have 120 minus 0. 120 minus 0 is 120 degrees. Next, OLP. OLP. OLP, again, we want to use the same number. So if I use the smaller number 90 for OL, then I use the smaller number 50 for LP. And 90 minus 50 is 40 degrees. Or if I use the other way, I could use 90 and 130. 90 and 130 has a difference of 40 degrees also. You have to use the same set of numbers. Remember, one set goes from 0 to 180. The other goes from 0 to 180 the other direction. So when you're using those, you have to read off the same set of numbers when the rays are like that, when you're not starting from 0. Okay, if you're starting from 0, look at the type of angle you have. See if it's acute, less than 90, 90, or more than 90, like an obtuse. And the next one was MLQ, and we really shouldn't have to measure that. MLQ is a line, so it's 180 degrees. Or this LM corresponds to 180, LQ corresponds to 0, and the difference is 180 degrees. The next one says classify each angle as acute, right, and obtuse. So looking up at the top, M, L, and N, that's an acute angle. It's less than 90. We can find its measure to make sure of that. We can tell by just observation, you can kind of tell. NLO, 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 that's a small, I'm sorry. NLO, oh yes, NLO, I was looking at, I was thinking it was NLQ, I put obtuse, but NLO will be another acute angle. Mistake number 1, Mr. Stevenson. Then MLP, MLP, that's an obtuse angle. It's more than 90 degrees. OLP, OLP is an acute angle. That's less than 90 degrees. OLQ, OLQ is a right angle, a 90-degree angle. And the last one, MLQ, is a straight angle, 180 degrees. Then we have a couple of questions down here. They say, look at the figure. Use the figure at the right for exercises 12 and 13. What is another name for angle XYW? XYW? Well, there's two names we could give it. We could give it angle WYX, just reverse the letters, making sure that the vertex in the middle, or we could just call it angle 1. Angle 1 is the easiest way to naming it because when we see the 1, we know exactly what angle. To name WYX, we have to trace around it. Same thing for the number 13. They say another name for WYZ. You could say ZYW or angle 2. Okay, either of those two names would work for that one. And the ones at the bottom where you had to measure using a protractor, in class I demonstrated this, but for those of you that were not in class because you're hybrid, what I did is my protractor is too large for the paper, really. So what I can do is I still put the vertex inside the little view finder point right there. And then I can slip a piece of paper up under the protractor and line it up with the other ray like this. And then from there, I was able to read the measure. And I said it's somewhere 33 to 34 degrees. See, we know it's acute. We're going up this way, so it's just past 30 at 1, 2, 3, or 34. It's 33 or 34. I mean, I don't expect perfect precision on those, but it is more than 30 degrees. So 33 or 34 degrees. Okay, I would take either one of those. The next one, we can do the same way. You know, put the viewfinder. You can tell it's greater than 90. It's more than being just, I hate to say this term, straight up, but it's more than just going at a perfect 90-degree angle. And I put on this one that it was 98 degrees because it seems to come out 2 degrees short of 100 here. Okay. All right. Number 16, when I measured it, it was a right angle, so that's why I put that little box there. That signifies a right angle. 17, I measured the same way, 125. And then number 18, which is such a large angle, it's hard to measure as well, but I said it was about 172. If you're off a degree or two one way or the other, it's not that major. We're not building materials or anything like that. We're just trying to make sure you know how to use a protractor to some degree. Play on words, some degree. On the next page, looking at these problems, the first one, number 19 at the top, says these two angles, JKL and CDE, are congruent. And we don't have a picture or anything, and we don't really need one. They tell us that JKL is 137 degrees. What would the measure of CDE have to be? Well, it's 137 degrees. The definition of congruent angles are angles that have the same measure. So if one has a 137 degree measure, the other one has to have a 137 degree measure. All right, on the next one, this is another one of those examples that I've said before that we have to be able to look at a picture and determine what we know. We have several angles here. I mean, I don't know how many, we could actually count. There's 1, 2, 3, 4, 5, and then combinations 6, 7. There's quite a few angles. We could even get more than that. But one thing we notice here is this angle has an arc, that angle has the same arc, so those two angles have to be equal. So I went ahead and put that they were 49 because the instructions tell me that FXG is 49, so that means that IXJ, which is congruent to it, is 49. Okay, now they also told me that FXH from here, FXH here all the way to there, I put a little larger arc in there, that's 130 degrees, so some way to signify that that's 130 degrees. Now something you have to pay attention to. Look at these two statements. They're different. This is saying an angle is congruent to. Angles are congruent to other angles. They're not asking me the measure of that angle, how big it is. They're saying what angle is it congruent to. This angle is congruent to this angle, IXJ. See, if that had the M in the front and this was equal, then we'd have put the measure like I'm doing on the next one. The measure of angle GXH. So here's GXH. How do we find that measure? Well, remember that large one was 130. I just got through saying that from the given. We just subtract 49, and that gives me 130. Angle addition postulate says that this angle plus this angle is equal to the larger angle. Okay, so it was 130 minus 49 is 81, and this time measure means they're looking for a number, so 81 degrees was that number. Next, name a straight angle in the figure. Well, there's two. Angle GXI, that would be a straight angle, and angle GXJ. Those are the two straight angles that you could name. Of course, you could name them the other way. IXF or JXG be the same angles, going around the same vertex using the same rays. Number 23 says that, again, it says angle congruent to angle. So we want a name of an angle. IXJ is congruent to GXF or FXG. It wouldn't matter. That's really the same statement we had in number 20, isn't it? It's just reversed. Okay, and I told you a lot of things we'll learn in geometry. We'll call it the converse. We flip it around. We learn geometry backwards and forwards, just like you learned algebra backwards and forwards. We learn order of operations, how to add, subtract, multiply, and divide, and we learn how to solve equations by reversing order of operation. All right, this is another algebra problem. Number 24, here's the picture, use the diagram. Diagram, picture's worth 1,000 words. So they say that RZT is 110. So I put a little arc in there trying to signify that the whole angle there is 110. RZS is 3S. SZT is 8S. So if I add these two together, they have to equal the whole thing. That's angle addition postulate. So the way I set up the problem, I said the measure of angle RZS, which is this one, RZS, plus the measure of TZS is equal to the whole angle RZT. And then we do something we'll talk about later. It's a property of algebra. We substitute. What's the measure of RZS? Well, they told us it's 3S, so we put that in. What's the measure of TZS? It's 8S, so we put that in. What's the measure of RZT? It's 110. So 3S plus 8S is equal to 110. 11S is 110. S is equal to 10. And if S is 10, over here to the side, I said, well, then the measure of RZS, which is 3 times S, will be 3 times 10, or 30. And the measure of angle TZS is 8 times 10, which is 80. Okay, so we found S, which they really didn't ask for, but we had to find in order to get the measure of these two angles. Okay, and the reason I keep saying they didn't ask for it, because I don't ever want somebody just to give me that, find S, and think they're finished. You got to find the measure of the angles. Next picture and problem, a similar picture. They tell us the measures of OZP. I put that in there, 4R plus 2. And PZQ, which is 5R minus 12. And then they tell me OZQ, the whole thing is 125. So we're going to do the same thing we did on the last one. This angle's measure plus this angle's measure is equal to 125. Okay, so I did the same thing, set up, this is angle addition, that this small angle plus this small angle is equal to the larger angle. I substituted in their measures, which were algebraic expressions, writing an equation, combine my R's, 4R and 9R, 4R and 5R is 9R, 2 and negative 12 is negative 10, add 10, 9R is equal to 135, R was 15. Then if R is 15, I did the same thing as I did before, plugged it into the measures. The measure of OZP was 4R plus 2, or 4 times 15 plus 2 is 62. The measure of PZQ, 5 times 15 minus 12, 75 minus 12 is 63. And notice, if you add 62 and 63, they're not equal. They didn't tell us these were equal. Remember, this one plus this one equals 125, and 63 plus 62 is equal to 125. So I know I did everything right, or most likely that wouldn't work. It'd be hard to make a mistake and get that to come out the way it's supposed to. All right, the next one, number 26. Elsa draws an angle that measures 56 degrees. Tristan draws a congruent angle. Tristan says his angle is obtuse. Is he correct? No, not if it's congruent, not if he actually drew it congruent to Elsa's. Congruent angles have the same measure. Okay, so they're both 56, and 56 is an acute angle. An obtuse angle is greater than 90 but less than 180. So my conclusion is Tristan is not smart. Okay, or he just didn't know the definition of obtuse. Right, next, Lisa makes a cherry pie and an apple pie. She cuts the cherry pie into 6 equal wedges and cuts the apple pie into 8 equal wedges. How many degrees greater is the measure of the cherry pie wedge than the measure of the apple pie wedge? So I said cherry pie would have been 360 degrees in a circle. If she cuts it into 6 slices, 6 is into 360, those would be 60-degree slices. The apple pie, 360 degrees divided by 8 slices, would be 45 degrees. So the difference in 60 and 45 lets you know that the cherry pie is 15 degrees greater than the apple pie wedge. Okay, the next problem, number 28. These two angles, JNR and RNX, are congruent. If the sum of the measures of the two angles is 180, what type of angles are they? Well, if you add these two angles together, they're equal to 180, and they're supposed to be equal to each other. Algebra tells us, and we will solve problems like this later on. We do a little substitution. We have to manipulate. We'll do proofs. We can substitute in for RNX the measure of J in P, and that means that the measure of J in P plus the measure of J in P is equal to 180. Or 2 times the measure of J in P is equal to 180. Dividing by 2 says J in P has to be 90. And if it's 90, the other one is 90, and 90 and 90, it's 180, so those are right angles. Those are right angles. I know that's a lot of explanation. Later on, we'll be doing things called proofs, and we'll have to give that kind of an explanation. And then the last one, a new pizza place in town cuts circular pizzas into 12 slices. So all we do is say 360 divided by 12, and each slice would have an angle of 36 degrees in it.